Hello everyone, I'm Teacher Michelle and welcome to another episode of Unang Math. For this episode, I will be covering the topic about perpendicular bisector of a segment. Okay, perpendicular bisector is a straight line. And this straight line bisect or divide another line into equal lengths. If we will recall, segment is a straight line that has a starting point and end point. Since it has a starting point and end point, that means we can bisect or we can divide segment into equal length. Comparing it to line and ray, okay, line and ray can extend endlessly. So that means we cannot bisect or we cannot divide line and ray into equal length. So perpendicular bisector is only applicable for segments. Okay, let's give an example. This is a segment and we will name this segment as segment AB. Since it has a starting point and end point, that means we can divide this segment into equal length. Okay, so we will draw a straight line to divide this segment into equal length. Okay, this straight line that divides this segment into equal length is what we call the perpendicular bisector. So in this figure, the perpendicular bisector of a segment is line L. Okay, let's name this as line L. Okay, that passes through the midpoint M. So where's the midpoint? This point. And we will call this one point M. So midpoint M of segment AB and is perpendicular to segment AB. So this perpendicular bisector is perpendicular to segment AB. Okay, why? Because there is right angle form. Okay, what are the properties of a perpendicular bisector? Okay, let's look at this figure. Okay, this is segment AB and this red line is our perpendicular bisector. So it bisects or divides segment AB into equal or into two equal lengths. So we have here segment AM and MB or BM. This length is equal to this length. So what are the properties of a perpendicular bisector? Okay, first, it passes through the midpoint M. So where's the midpoint? This point of segment AB. Okay, next, it is perpendicular to segment AB. So this perpendicular bisector is perpendicular to segment AB because there is right angle form. And it divides segment AB into equal length parts. So this is our perpendicular bisector. It divides this segment AB into equal length. So this segment AM, okay, is equal to segment MB or segment BM. Okay, so if we will write using symbols, okay, segment AB is perpendicular to this line L. Okay, and segment AM, this segment, is equal to segment BM. Okay, this time, let's answer this concept check question. Okay, line PM, where's line PM? This line is the perpendicular bisector of segment AB. So where's segment AB? Okay, from this point until this point, this is segment AB. Okay, given that AM is equal to 5 centimeters, or segment AM is equal to 5 centimeters, and angle PAM is equal to 50 degrees. So where's angle PAM? Okay, PAM. So this angle, this is 50 degrees. Okay, we have to fill in the appropriate values. Okay, let's have number 1. Okay, so line PM, where's line PM? This is line PM or our perpendicular bisector. Line PM blank segment AB. So this is segment AB. So it means line PM is perpendicular to segment AB. So what is the symbol for perpendicular? This symbol. Okay, what about number 2? Okay, segment BM is equal to how many centimeters? Okay, where's BM? This point up to this point, it's line BM, segment BM. Okay, take note, since this is our perpendicular bisector, it divides this segment BM into equal length. So if this is 5 centimeters, that means this is also 5 centimeters. So BM or segment BM is 5 centimeters. Okay, what about segment AB? Okay, AB. So this line. So 5 plus 5, this is equal to 10 centimeters. Okay, and lastly, how about angle APM? Okay, angle APM is APM. So this one, APM, so this angle. Okay, since this is 50 degrees, take note, this is a triangle. And triangle is equal to 180 degrees. Okay, since this is 50 degrees, and this angle is a right angle, so this is 90 degrees. 90 plus 50 is 140 degrees. So we have to subtract 140 degrees from 180, and this is equal to 40 degrees. So this is 40 degrees. So angle APM or this angle is 40 degrees. Okay, this time, let's answer this simple problem. Okay, in the figure, line L is the perpendicular bisector of segment AB. Given that segment AB is 10 centimeters, segment BP is 6 centimeters, and BQ is 8 centimeters. What is the distance from point B to line L? Okay, this line or this red line is our perpendicular bisector. Okay, it divides segment AB into equal length. Okay, according to the given, segment AB is 10 centimeters. So from here up to here is 10 centimeters. BP, here until here is 6 centimeters. BQ, from this point up to this point is 8 centimeters. The question is, what is the distance from point B to line L? So point B to line L. Okay, take note, from point B to line L, we have to get the shortest distance or the distance from B to the foot of the perpendicular. So the shortest distance or the foot or the distance from point B to the foot of perpendicular is, this is 5 centimeters because A to B is 10. So this length is equal to this one. So this is equal to 5 centimeters. So from point B to line L is 5 centimeters.